question? Yeah. Let's have a look. See, so where's the question?
Oh, on page 1.
Yeah, let's have a look here. B. So that is x4 over 4. That's x cubed over 3. That's 2 over 2. That looks okay. And you put in 8 first, so that's fine. Okay, so I'm going to assume that that's right. And then putting in the 4. And you got this. And you should minus them.
Which calculator?
Yeah. Who knows? I mean, you'll just have to retype. Everything is looking fine from here. Yeah, the steps are right. So it's possible just a calculation mistake. Now, what I was just about to say is you can check your answer on the calculator as well, because you can put integration into it. Have you got this calculator?
Yeah.
Why don't you check that if my answer's wrong? Actually, you know what? I'll do this as an example. Yeah. On the calculator. Yeah. Okay. Yeah. We'll do that then. We'll do that. So we'll continue now, guys. We'll continue. And before I hit the next lesson, I just want to show you your calculator can do integration. Now, I'll show you. Now, maybe my answer might be wrong here in the book, so we can check. Are you sure? Okay. Well, we can check with the calculator. This is useful in the exam because you can check if your answer is right. So you see here, you have an integrate button. So I want to integrate from 4 to 8. And what's my function here? It's 16x, what is it? Cubed. Yeah, what's next? Plus 9 alpha x squared plus 18 alpha x minus 17. 17068. No, my answer's wrong then. Unless I mistyped. Oh, I have a wrong sign, sorry. That was a minus 9x squared, wasn't it? Okay. 14380. Useful for the exam for checking your answer. Yeah. Okay, let's continue now. Got that? Yeah. You've seen this before on the calculator? Yeah. Okay. So next lesson now. So last week we were talking about the derivative. On my graph, what does the derivative represent? So if I calculate the derivative at this point, what am I getting? More precisely? What about the tangent? The equation of the tangent? What? No, turn your brains on full power, please. When I calculate the derivative, what am I getting? No. The slope, yeah. Yeah, you know. Full power, please. The slope of the tangent. Okay? So when I calculate the derivative, I'm getting the slope of this line. Yeah. You can feel my frustration, right? So, what I haven't said to you yet is what does the integration represent? Now, you've said what the integration represents. Yeah. So, if I had a function fx here, and I integrate from, let's say, 1 to 2, or 1 to 5, whatever, a to b, what I'm actually calculating is the area. Believe it or not, integration actually gives you area. Area is integrating from a to b fx dx. This is very, very useful. Very, very useful. Although there is one condition I must state here. This only works provided that the fx is positive when x is between a and b. And that's a big condition. Okay? This formula breaks if you do not maintain that f is, if f does not stay positive. Now you might say, well, what's the deal if it's not? So like if you had this situation, so situation 2 is if your curve was under the axis and you have A and you have B and you want to know what's the area here under the curve. Well, the good news is the area, so this is when fx is negative between A and B. The formula is only slightly different. It's minus integrate from A to B fx dx. Or, you know, if you want to think about it another way, you can put the minus inside and say you integrate minus f of x. Whichever way you prefer. It's the same thing. Now, there's a third situation which is a problem. If I scroll down to situation 3. Oh, you need the first one? Yeah.
How could A be negative?
It's not. If you calculate this, you'll get a positive.
Oh, I see.
Yeah. We'll do examples.
What if it's 0?
Zero's okay. What part?
Either of them, because it's like greater than or equal to 0.
Zero's okay. There's no problem if this hits the axis or if this starts at the origin or whatever. There's no problem. Okay, situation 3 now. This is the worst situation. It's when you have something like this. And you want the area here and then the area here. Yeah, it's a bit complicated. So here's A and here's B. And this point here is C. So in this situation, the area is not simply a single integration. You actually have two sub-problems here. If you want the area, you'll have to integrate first from A to C.
Minus C.
Yeah, and that's it. And then minus integrate from C to B. So you've turned situation 3 into situation 1 plus situation 2. Okay. That's common enough in the exam. They usually give you some function that cuts under the axis.
Isn't that just 1 over cos squared x?
What? 1 over cos squared x?
Yeah.
Oh, this?
Yeah.
Where is this coming from?
It looks like a tangent line, so, right? So that
This looks like a tangent?
Is it?
Ah, no. Kinda. If you squint your eyes and tilt your head to the side, maybe.
This makes it look like we're subtracting one integration from the other.
Yeah, but really it's plus a minus of this. Yeah, you're right. It looks a bit strange. You're taking one integration away from another, but it works out. And the last situation. So in all the 3 situations above, you've been looking for the area between the curve and the x-axis. So situation 4 is when you have one curve, let's call it f, and another curve underneath it called g, and you have from here is A and here is B, and you want the area between f and g. And we should make the further condition that this area is one piece and not 2. In other words, I don't want a situation like this where it's 2 pieces. Okay, I'm only looking at one region here. Yeah. Does anybody know what happens here? Now you might be able to figure it out, because you can think about it like this. You could get the area underneath f, then you can get the area underneath g and subtract. So you could integrate f, integrate g, and subtract. You can also do it the other way around. You can subtract first and then integrate. So here the area is actually AB upper minus lower integrate. Quite handy. So the upper function minus the lower function integrated. That is at 11. Right, so there's lots of theory here. Let's have a look at some examples.
Sorry, one
Yep.
second. If the shaded area is outside, so do we find integration of the...
With the shaded area here,
Yes, outside.
like you mean underneath?
Yeah.
Oh, so if you have all of this?
Yeah.
Yeah, what
No, but
integration?
without the inside, without the inside.
So you mean something like this?
Yeah.
What would integration would that be?
What is it?
G.
The upper?
Just G.
Just G.
The lower, yeah.
Oh, yeah.
Yeah, yeah. And what would this one be? Just that then. Yeah. It's okay. Yeah. I prefer to think about it like this: AB upper function minus lower function. Yeah. Easier. Right. Let's have a look at some examples. Can I scroll down? Yeah. So, the first one. Let's keep it easy to begin with. So let's say you have a function like, let's just say this function here. Y equals x squared, and here is 1 and here is 2, and I would like this area here. Let's calculate that. Right, so what integration problem is this? Integrate 1 to 2 of x squared, and that's x. Try again, Mubarak. Over 3 from 1 to 2. First I put in the 2, then I put in the 1, and what do? Minus, so my answer is 7 over 3. Let's confirm this. Integrate from 1 to 2, alpha x squared, and 7 over 3 is correct. Alright, that's example 1, if you can write that down.
That's the area under.
That's the area under the curve between 1 and 2. That's perfect. Right. You got a question, or are you just looking for inner peace? I don't have any on me. Sorry. 14. What? All right. Next example. Okay. So what we will do next, let's do an example where it cuts into the x-axis. Yeah? Okay. So, let's say we have a function like
Minus 2 x squared.
just lower it down. No, we can do a little bit more interesting than that. No, let's make it boring. Let's say we have this function here. This is the function y equals 1 minus x. What's this point here?
1.
1. And this point here?
7.
What number? 1. Okay, and let me just mark off 2 here. So I would like this area and this area here. Okay? So there are 2 integrations to do. So what is the first integration? From
0 to 1.
Now from 0 to 1 of 1 minus x plus negative
From 1 to 2.
1 to 2 1 minus x. You don't need to write the plus. I'm just thinking about it as this area plus this area. Okay. Right. So let's integrate here. So this becomes x minus x squared over 2, 0 to 1. And this one here becomes x minus x squared over 2, 1 to 2. Right, let's put in 1 first. So 1 minus a half? A half. Let's put in 0. 0 minus 0? 0. And I minus. Okay, let's put in 2. 2 minus 2 squared over 2. That's 2 minus 4 over 2. That's 2 minus 2, which is 0. Isn't it? And now let's put in 1. Yeah. 1 minus a half? A half. Now just be very careful with your signs. This minus is because of the two limits, and this minus is from the original formula. So in total I have a half minus a half, which is plus 1. Now there is a way to check this. Cast your mind back to when you were in elementary school. You had your little milk carton, your packet of crayons and so on. You remember how to work out the area of a triangle?
Yeah.
Half the base by the height. What's the base here? 1. And the height? 1. So a half, 1 by 1 is a half. So the area here is a half. Base? 1. Height? 1. A half 1 by 1? A half. So the total area? 1. So the answer is right. Yes?
Or you could look at it as one whole unit and then it's 1.
Yeah, there's many, many ways to look at it. It's because it's simple. It's just a triangle. Yes?
But
Yeah, for this one, 18.
but
Yeah?
what if you have something like 1 over x?
What? Yeah, you could have that. Yeah, it's no problem. The graph for it looks like this.
Yeah, like, but then you would have like 3 or 2.
3 or 2 what? Yeah.
Parts, wouldn't it?
No, just 1. You know, like here and here.
Isn't 1 over x 4?
Yeah.
That's
They
four.
won't ever have you look at both regions at the same time in the exam. They'll only have you looking at, like, say, the positives. You know.
Did they ever give us a question where they give us the area and the function and they flip to find the point?
That's interesting. They've never done that. I can't see why they can't, but they've certainly never done it in the exam. So you have to work backwards from the area. Yeah. Well, you kind of did one kind of like that. In the last lesson, the last question, I asked you to find the limits.
Yeah.
So it's kind of like doing that. Yeah. That's it. Yeah. It never occurred to me as a question, and I guess whoever writes the exam, they never imagined that as a question.
Hopefully it doesn't.
But to answer your question, they have not done that, but there's no reason that they wouldn't do it, apart from not having the imagination to think of it. Yeah, you should write maths exams. Okay, let's continue down. Yeah, that's fine. Yeah. Right, I'll give you one to try. Here's a quadratic. Y equals x squared minus 3x minus 2. I want this area. Calculate for me.
What are the
Oh no, told you all you need to know. Oh, sorry. Plus 2.
the roots?
Of course you can. I'm sure I know this. You know this.
And then you would get like the two points.
I know.
The point of calculating. The percentages to yeah,
What I'm going to do for the students next year is I'm actually going to put, I see there's lots of space at the bottom of 84. I'm going to put that question you suggested as a question 23 on the page.
Or you can put it in the end of the semester.
No, I don't write the end of the semester, so
not anymore.
not anymore. Okay. No? Okay. Got that? So what are the roots here?
1 and 2.
1 and 2. So the integration will be minus 1 to 2, x squared minus 3x plus 2 dx, which equals minus integrate, so that's x cubed over 3, 3x squared over 2, 2x and 2, 1. Right, so minus bracket, put in the 2, put in the 1, and subtract. So that would be 8 over 3. 2 squared is 4, over 2 is 2, so that's a minus 6 plus 4. And then put in the 1, so that's 1 over 3 minus 3 over 2 plus 2. Has somebody bashed this out? What did you get?
2 over 3.
So the final answer? 1 over 6. Yeah.
What?
I'm still confused with the minus at the outside. Doesn't that make any answer in between the brackets become minus?
Yeah, but the answer inside here is minus. So you've ended up making it plus. Right, we'll do one more when you're ready. I want you to try this one for me.
Yeah. Minus 1 over 6.
Yeah.
So this here is y equals x. Oh my goodness. Steady. Will do. And this one here is y equals x cubed. Cubed. So I would like this area and this area. Yeah. Yeah. Now we're talking. Hmm? Yeah, y equals x. Did you integrate from -1 to 1?
Yes.
That's wrong. Because this is case 3, isn't it?
We don't know the
Minus 3, so we,
Yeah, it means find them.
you equate them, then.
Yeah, that's it. Yeah.
Hmm?
Look at the case 3 at the start of the lesson. Do you remember we looked at like 4 cases or something?
Yeah. Yeah, but we have it on.
Minus 3 to 0,
Yeah.
and then 0 to minus 3.
Not -3 or 3.
0. 1 over 2.
No. Alright, I better do this now.
No.
You think you can get it?
Yes.
Solve it. You're looking for the intersection points, true?
Yeah.
So, simultaneous equations. You have y equals x cubed, y equals x. Equate them. X cubed equals x. X cubed minus x equals 0. Yeah. Okay, I need to do this now because it's taking too long over there. Come on. Right. Right, so the first thing you need to do is figure out where these lines intersect. So you need to solve this system. So solving is not a big deal here because you can equate. You can say x cubed equals x. So that means x cubed minus x equals 0. That means x by x squared minus 1 equals 0. That means x by x minus 1 by x plus 1 equals 0. That means x equals 0 or plus or minus 1. So obviously this is the minus 1, that's the 0, and that's the 1. But you could have guessed this at the beginning. What value of x is the same when you do nothing and cube it? Well, 1 or minus 1. So our problem is we have to integrate from minus 1 to 0, what? X cubed minus x. Plus, and now we have to integrate from 0 to 1 of what? X minus x cubed. Right, so let's see what we get here. This is minus x4 over 4 minus x squared over 2 minus 1 to 0. And this is x squared over 2 minus x4 over 4, 0 to 1. So this is minus bracket, put in 0, put in minus 1, plus bracket, put in 1 and put in 0. Right, if I put in 0, I get 0 minus 0. If I put in minus 1, I get 1 over 4 minus 1 over 2. If I put in 1, I get 1 over 2 minus 1 over 4. And if I put in 0, I get 0 minus 0. So this is a quarter minus a half is minus a quarter, isn't it? By minus is a quarter. By another minus is minus a quarter. And this is a half minus a quarter. Oh, hang on. That's not.
Zero.
Let's be careful with our signs. A quarter minus a half is
Minus quarter.
minus a quarter. Yeah, 0, 0. Okay. And don't confuse your hungry teacher. A quarter minus a half is minus a quarter, true? Another minus makes it plus. And another minus makes it minus.
So it is minus. Why would you leave that minus?
It's minus a quarter.
You did.
So it's
Minus.
I've lost track. What was I on? Plus or minus? I was on minus.
Minus quarter.
Okay. A half minus a quarter. No. I'm just what? Obviously, I'm just trying to figure out where my sign mistake is.
There is no sign mistake. The question is wrong. I've been saying that since the beginning. You guys.
No, it's not wrong. It's not wrong. It's correct. Yeah. So we need to figure out where my sign mistake is. X cubed minus x, and this one is x minus x cubed. Ah! Here's my mistake. These are pluses. I don't have case 3 here. I was tricked. I tricked myself. I thought it was case 3. It's not case 3. It's case 4. The area between two curves.
Oh yeah.
I know, don't act like, oh well. I was just testing you, teacher. Yeah, okay. So it's a quarter plus a quarter is a half. Yeah, just to clear up here, where's my picture gone from earlier? In case 4 here, you actually don't care where it is. It could be even like down here, and it's still the same. Yeah, it's f minus g. You don't care in case 4. You only care that it's between two curves.
That's exactly what I did, and I still got to 0.
No, you shouldn't get a 0 if you do it like this. It's a half.
Yeah.
What time is it?
34. What's that?
But it's 1. That's why
I told you it's 3.
Yeah.
What did I say it was 3?
didn't work. So I used 3 and you because I didn't equate. So stupid.
1, 3, 17 and 22.
I told you to equate.
If you can try these for a few minutes and then we'll finish.
What time
So
was that?
1, 3, 17, 22. This one's at 35.
5 minutes.
I go with it.
Can I close this?
No.
Not yet? Okay.
Which ones do you want to do?
There it is. 1, 3, 17, 22. Daniel, sit down. You're trying these questions.
So you said last time you're gonna check.
Yeah, but you're packing up like you're never going to return to do your maths. Are you going to return? Okay, well, you can leave your stuff open. It'll be ready for you when you come back. No, take the stuff out. Okay, now I feel confident you'll return. Okay, off you go. Thank you. Yeah.
I have multiple, many small questions.
Go on.
First off is, why did you swap between x minus 3 and x?
Because the upper and the lower swapped. In this case, the upper was the blue one, and in this one, the upper was the red one.
I see.
Okay?
Second part is,
Yeah? Huh? Say that again, yeah. So here the upper function is the blue one, which is x cubed. But here the upper function is the linear one, which is x. So that's why these are opposites. Because the upper here is x cubed, but the upper here is x. Yeah?
Okay. Second question is, why is this not case 4?
It is case 4.
Why is it case 3?
Case 3 is when you're getting the area between the curve and the x-axis. So it's see, this is what actually confused me. It's so close to case 3. But case 3 would have to be like this. Let me show you. Case 3 would be if you had a cubic and I asked you for this area and this area. So it's extremely close to case 3, but technically not.
But imagine the x-axis on a grid.
Instead of
Yeah, it's a bit like that, yeah.
the second part, you're not looking for the area like above the line, you're looking for the one under. Is that what you mean?
In my case 3.
No, this.
Oh yeah, the area, yeah.
Both of them are under the curve of yx cubed.
No, they're both under x cubed or x, depending if you're on the left or the right.
But both of them are under.
They're under, well, rather they're between two functions. They're between x cubed and x.
Yeah, but in case 3, you're looking for the
Under
area
a curve, a single curve, yeah. Between the curve and the x-axis.
between the curve and the x-axis. Here you're looking between the curve and another line.
In this one, yeah. Another line which is not the x-axis. Okay, are you trying these? 1, 3, 17, 22. Yeah. You'll come back? Oh, Mosa, what happened to you this morning?
I don't know why I'm getting 0. I can't, like...
That's his story too. What part? Are you typing it in on your calculator?
Yes, the same thing.
You're typing this exact same line. Show me what you typed. Show me what you typed. You got it?
No,
Alright, give it another go.
Do we have to know these?
No, they're in the formula book, so.
But
They're semester 2. Yeah. Oh, let's see what's happening. Okay, so far so good.
I'm getting a negative as well. I don't understand.
Something's a bit funny with your brackets here, hang on. Right, so the first one, you have bracket minus 1 power 4 over 4 minus 1 squared over 2, close the bracket. So that's fine, right? Plus bracket. You didn't bother to put 0 in the first one because it was 0, right? So in the second one you've put in 1. So 1 squared over 2 minus 1 power 4 over 4. Yeah, so you've typed in something. Oh, here! It's in the first one. You forgot this minus.
Yeah. Yep.
Here. You just forgot this, Mosa, this one here. You never typed this in on the calculator.
Huh?
What do you want to say?
No, on the first one. You use it.
Just type it. What do you need?
Okay, close this now.
I want to see what.
Close it?
Which minus? This one?
That one, yeah, I typed that in.
Give me the
Okay,
You-
why? Why did you put it?
Because it's there.
One,
Because it's the 0 minus this value. You never put in the minus. Yeah.